In this video, I will explain Tombstone effect, known as the Manhattan effect, chip lifting effect, Stonehenge effect, drawbridge effect. That effect occurs during the reflow process of solder paste on the PCB in oven. This effect occurs with SMD components like a capacitor, like a resistor, different sizes. Lifts on one contact pad and detaches from other pad. I will tell you 6 causes of this defect and how to prevent it. Watch this video until the end, hit like, leave a comment, subscribe to my YouTube channel. Thank you in advance. Let's go. First causes: incorrect reflow profile, creating temperature differences on the two pads. In reflow oven, different profiles are used for leaded and lead-free solder pastes. In one of my upcoming videos, I will show you how to create profiles for oven. In this case, in first case, the conveyor speed is too high. The PCBs does not spend enough time in the oven's second zone to stabilize its temperature. You need to align the profile with solder paste manufacturer recommendations. Then test the actual temperatures in the oven zones using thermal profiler. It's very important. The correct profile will preheat the PCB and components evenly by the time the solder paste melts. In one of previous video I talked about temperatures for manual soldering. There is a link on description. Second cause: lack of thermal barrier on one of the pads. One pad heats up faster than other because it's connected to large copper area that dissipates heat. This prevents both pads from reaching the same temperature. The component is pulled by the surface tension of molten solder to the pad where the solder melts faster. To fix this, the PCB must be redesigned for creating thermal barrier around pad. Like this video, leave the comment with your opinion and I will continue. A third cause: a via through hole located on one of the SMD pads. When a via is placing on one of the two SMD contact pads, heat leaking to the metallized through hole, disrupting uniform heating. When you're designing your PCB boards, place vias outside the pads and provide thermal relief. It's very important for soldering. Additionally, molten solder may leak into the via, shifting the surface tension difference to the other pad, which then pulls the components toward it. The solution is to redesign PCB. Now with 4 causes: different volumes of solder paste on two pads. If one pad receives a larger volume of solder paste, it creates excessive surface tension when melting, when soldering, that pulls components toward it. The problem is often caused by the stencil used to apply solder paste. Make the stencil apertures the same for this SMD component. Fifth cause: different sized pads of symmetrical SMD component. Different pad sizes can cause a slight temperature difference. Another common mistake is different stencil apertures for the pad of symmetrical SMD component. The result will be unequal volume of solder paste. This needs to be corrected at the PCB and stencils design stage. And now last 6 cause: the poorly made stencils that clogs with solder paste. Low quality stencils and apertures can cause the solder paste to get stuck, resulting in incomplete solder paste application to the PCB. Here a difference in surface tension is creating between two contact pads. The pad with a larger volume of molten solder paste has a higher surface tension. I want to ask you about your opinion and your experience. Let me know in the comments. In conclusion, make PCB corrections at the design stage. You can eliminate future PCB soldering issues, avoid costly repairs, significantly improve the quality of your PCB. Check out my other videos in my channel to improve your skills. Thank you for watching. In description on this video you can find link to my Instagram, to my website with soldering fluxes. Thank you for watching. Bye bye.